Science education should not depend on where a student lives or how much money their school can afford to spend on laboratory equipment. However, many schools in rural and vulnerable communities have limited access to scientific tools such as microscopes due to their high cost. As a result, students often have little opportunity to perform hands-on experiments and develop scientific observation skills. At the same time, millions of electronic devices are discarded every year, including smartphones that contain valuable optical components that are rarely used. To address these challenges, I developed Zoom, a low-cost portable microscope designed for children and teenagers between 10 and 15 years old. The project combines educational accessibility, sustainability, and digital manufacturing by reusing lenses recovered from electronic waste and integrating them into a compact modular device that can be carried as a keychain or pendant. The design process began with research into educational inequalities, existing portable microscopes, and electronic waste reuse. From this research, several users' needs were identified. Access to individual scientific equipment, portability, ease of repair, low manufacturing cost, durability, and the ability to encourage interest in science through direct experimentation. The development process started with brainstorming sessions, concept generation, sketches, and technical specifications. Multiple digital models were then created to explore different mechanisms and structural configurations. These concepts were tested through several 3D print prototypes, allowing rapid iteration and evaluation of different solutions. To understand how to simplify a conventional microscope, I first studied its optical principles. A traditional microscope used multiple lenses to magnify an image by refracting light passing through a sample. For Zoom, this principle was simplified using recycled convex lenses recovered from smartphones, cameras, and laser pointers. One of the most important stages of the project involved experimental testing. Different lens combinations, lens orientations, and distances between lenses were evaluated to determine the most effective configuration. Tests were conducted using systems with 2 and 3 lenses, although adding more lenses increased magnification. It also made the systems significantly more difficult to align and focus. Small positioning errors often result in blurred images. The resulting product is a lightweight microscope manufactured through 3D printing and assembled from only a few components. Its modular design allows the optical, electronic, and structural elements to be easily replaced if damaged, making maintenance straightforward even in resource-limited environments. The estimated manufacturing cost ranges from approximately 64 to 90 Mexican pesos or about $3.525, demonstrating the economic feasibility of the concept. Several opportunities for improvement were identified during development. The focusing mechanism remains one of the most challenging aspects of the design and could be redesigned using simpler manual adjustments or magnetic-assisted positioning systems. Another important opportunity is the development of a modular optical system. The current prototype uses a fixed 2-lens configuration. However, future versions could incorporate interchangeable lens modules that allows users to add additional lenses as their educational needs become more advanced. This would enable students to progressively increase magnification levels and continue using the device throughout different stages of their scientific education rather than replacing it with a completely new microscope. Zoom demonstrates how recycled materials, digital manufacturing, and user-centered design can be combined to create an accessible scientific tool that helps reduce educational barriers.